Okay, so this video is on absolute extrema and how to calculate absolute extrema. So the first thing that we are going to be talking about is what is an extrema, which we actually did this in class already if you were there. So extrema is just that we're talking about the absolute minimum or the absolute maximum on an interval, and this notation here, like f of c is less than or equal to all f of x, just means there's a value that's lower than every other value on an interval, and the maximum is f of c is greater than or equal to all f of x. So basically there's a highest point on the interval. So for an extrema to be guaranteed, we have to see that f is continuous on a closed interval. Then it will have both a maximum and a minimum on that interval. So you'll look at this first section. A looks like that. So basically this is a closed interval. In this interval there's a minimum, it happens here at this vertex, and then there's a maximum, and it's up here where at the end point of the graph. If f is continuous on an open interval, it might have a max, it might have a minimum, but in this scenario there is no maximum because you can't say like a hole is a maximum. So basically this graph keeps getting closer and closer to the hole, but it doesn't actually reach it. We can't identify a maximum. In figure C, the graph isn't continuous, and so if you look here, the lowest point should be this hole, but again, a hole cannot be a minimum. So what's going on there is, because that hole was removed and moved up here, there isn't actually a minimum on that graph. There is, however, a maximum on that specific graph, but it's not guaranteed. Okay, so relative extrema are just local points that are the highest and the lowest. There's another video about local extrema that we're going to watch, or that you're going to watch as well. A local extrema just means there's a hill or a valley in the graph. You guys have already kind of looked at this when you did graphical analysis, so this shouldn't be unfamiliar. So relative extrema, or relative max and mins, will occur at critical values or critical points. Critical points occur in one of two places: when the derivative of the function is 0 or the derivative of the function is undefined. So these are the two kind of conditions that we look for. In this scenario in A, this is what it might look like if f prime of x is 0. It's a very smooth curve. At this point we have a relative maximum. And in this scenario, the absolute value function, this happens when the derivative doesn't exist, is where the minimum is. So our guidelines for finding absolute extrema on an interval is that we are going to find all critical values. So we're going to find the derivative, determine where that is 0 or undefined. Then we're going to evaluate f at each critical value or each critical number. And then you're going to also evaluate f at each endpoint. The least value is the minimum, the greatest value is the maximum. So in this example, we have this function, which is f of x equals 3x to the fourth minus 4x cubed on a closed interval from -1 to 2. I know this function is continuous because all polynomials are continuous. So step 1 for this graph is you're going to find the derivative, find f prime, and you're going to set it equal to 0 or find where it's undefined. In this scenario, there isn't going to be a place where it's undefined, so we're just going to be setting it equal to 0. So the derivative, we bring down the 4 and we get 12x to the third, and then we bring down the 3 and we get minus 12x squared. So we're going to be setting this equal to 0, and we're going to factor out at 12x, and we end up with x minus, or sorry, at 12x squared, and we get 12x squared times x minus 1. Setting that equal to 0, I have 12x squared equals 0, and x minus 1 equals 0. So in this scenario, x will equal 0. In this scenario, x will equal 1. So at this point, we're going to evaluate every value of the critical values and the two endpoints into the function. So we're going to find f of -1. We're going to find f of 0. We're going to find f of 1. And we're going to find f of 2. Any of these could be the absolute max or the absolute min. So f of -1 is 3 times -1 to the fourth minus 4 times -1 cubed. And we end up with 3 plus 4, which is 7. And then when we plug in 0, we end up with 0. If we plug in 1, we have 3 times 1 to the fourth minus 4 times 1 cubed. So f of 1 is negative 1. And then f of 2, we get 3 times 2 to the 4th minus 4 times 2 cubed. So we have 3 times 16 minus 4 times 8. So that's 48 minus 32, which is 16. So I would write the absolute min is negative 1, and it occurs at x equals 1. The absolute max is 16, and it occurs at x equals 2. So you can see the previous example I have right here. This is the absolute minimum on that interval. And over here, this is the absolute maximum on that interval, because the interval only went from here to here. Okay, so this is our second example and our last example. Again, we're going to find the derivative, and I'm going to have f prime of x. Let me erase that, sorry. We have f prime of x equals 2 minus, and then I'm going to bring this down, and we end up with 2x to the negative 1/3. So I'm going to have to look at where this function is both equal to 0 and where it's undefined, because I have this negative exponent here. So I have 2 minus 2 over the cube root of x. And so this is f prime of x. I'm going to go ahead and look at making this into one fraction. So it's going to be 2 cube root of x minus 2 over cube root of x. So this will be 0 when the numerator is 0. So I'm going to set the numerator equal to 0. And it will be undefined when the denominator is 0. So I have the cube root of x equals 1. So this would happen when x equals 1. And I have the cube root of x equals 0. This would happen when x equals 0. So now I'm going to find all critical value, I'm going to evaluate it at all the critical values, and I'm going to evaluate f at the endpoints. So I'm going to find f of negative 1. I'm going to find f of 0. I'm going to find f of 1. And I'm going to find f of 3. So f of negative 1 would be 2 times negative 1 minus 3 times negative 1 to the 2/3. Again, to the 2/3 just means you're going to cube root it, and then you're going to square it. So this ends up being negative 2. When I cube root negative 1, I get negative 1. When I square it, I get positive 1, so minus 3. And that's negative 5. F of 0 is 0. F of 1 is going to be 2 times 1 minus 3 times 1 to the 2/3, which ends up being 2 minus 3, which is negative 1. And then f of 3 would be 2 times 3 minus 3 times 3 to the 2/3. F of 3 will be 6 minus the cube root, 3 times the cube root of 9. The cube root of 9 is around 2 point something, so this is going to be pretty close to 0. It's a little less than 0, but it is not lower or higher than any of the other values. It's slightly less than 0. So actually our highest value will be f of 0 equals 0, and our lowest value will be negative 5. So I would write that the absolute min is negative 5, and it occurs at x equals negative 1. The absolute max is 0, and it occurs at x equals 0. And again, this is just a picture of that function. So this was our lowest point on that interval. and this was our maximum point on that interval. And the interval again was from -1 all the way to 3. And again, 3 was slightly less than 0.